So this section 5.3, is about solving equations. And in particular, the kind of equations that you're going to be working with to solve are trigonometric equations. So what's a trigonometric equation? It just means that you have an equation where instead of having variables like x or y, you have equations that look like sine x or sine theta. So we're going to try to solve those equations. We'll use the regular kinds of techniques that we use to solve equations. We'll look at some strategies for those. But we're also going to need to know how to use some basic trigonometric identities in order to solve some of these equations. Okay, so first thing. So we want to be able to solve an equation, right? So let's say I have an equation like y equals cosine x. And it says, all right, find the value of x when the cosine of x equals a half. So, in other words, find the value of x that I could plug in that will allow the output or the y value to be 1/2. So the blue line is the cosine, and the red line is the value y equals a half. And basically, you're just looking for all of the places where the cosine equals a half. And you can see on this graph, there are lots of places where the cosine of x equals a half. So what are those places? Well, right here, what value of x is that, right? That's the value x equals 5 pi over 3. Let's see, how about right here? This is the value x equals pi over 3. How about over here? This is the value x equals 5 pi over 3. How about over here? This is the value x equals 7 pi over 3, right? In other words, it's coterminal with pi over 3. So essentially what we're doing is we're finding the two angles that are on the unit circle. So like pi over 3. Oops. So pi over 3, and then 5 pi over 3, and then the rest of these guys, this one, and this one, and here's another one over here, this one. The ones that are boxed in yellow are all just coterminal with the two original answers that show up on the unit circle. So the goal is to find the two answers for x that work in the unit circle, and then look at how we could find all the coterminal values of those. So let's look at the first equation. It says solve 2 tangent x minus the square root of 3 equal to tangent x. So if I was doing this and it was just algebra, it might be something like this. Let tan x equal to b. Okay. So then this equation becomes 2b minus the square root of 3 equals b. As soon as I replace tan x with another variable, it's really not that hard of a problem to solve, right? How would we solve this? Subtract b from both sides. I'd get b minus root 3 equals 0. And I'd get b equals root 3. Not a hard problem to solve. We weren't solving for b, we were solving for tan x. So tan x equals the square root of 3. So here's the question now. Here's the unit circle. Which values of x have a tangent of root 3, right? So there's one right there. Pi over 3 has a tangent of root 3. The other place where the tangent is positive is in the third quadrant. So a 60-degree reference angle in the third quadrant is going to give me 4 pi over 3. So x is either going to be 4 pi over 3 or pi over 3. And there's two possible answers for x. One where the tangent of x is in the first quadrant, and one where the tangent of x is in the third quadrant. So not only do these two answers satisfy this equation, but all answers that are coterminal with 4 pi over 3. In other words, I could have spun all the way around and then went to 4 pi over 3. So I should probably list this as 4 pi over 3 plus any multiple of 2 pi that I could add, right? Meaning I could spin forward or backward around the unit circle. And also pi over 3 plus any multiple of pi, or a multiple of 2 pi that I could add. And that is my final answer. Okay, let's take a look at another problem. All right, so in this problem, I'm going to solve it a similar way. It's just an algebra problem, right? So if it helps you, you can write sine x equals b. And then you could write this as 4b squared plus 1 equals 4. Okay, so if I'm going to solve this for b, I'm going to subtract 1 from both sides. 4b squared equals 3. Divide both sides by 4. B squared equals 3/4. And then lastly, take the square root. So here's a really important thing, is when you take the square root, remember that you're going to get positive root 3 over 2, and you're also going to get negative root 3 over 2. So again, we weren't solving for b, we were solving for sine x, so let's replace this with sine x. For what values of x is the sine equal to positive root 3 over 2? And for what values of the sine, for what values of x is the sine equal to negative root 3 over 2? So let's go back to the unit circle. Okay, there's my unit circle. And find all the places where the sine is equal to positive and negative root 3 over 2. So the sine is equal to root 3 over 2 anytime you're at 60 degrees, right? So that's going to be positive pi over 3. That's one of the values where the sine is equal to negative root 3 over 2. Positive root 3 over 2. Here's the other one. 2 pi over 3. So 60 degrees in the second quadrant. Now here's another one over here, 4 pi over 3. And lastly, 5 pi over 3. So there's all of the angles that satisfy this equation. And again, I could either write those angles, like if I was only giving the answer over the unit circle, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Or I could also give all of these answers written with coterminal values. So in other words, adding or subtracting multiples of 2 pi. So how did I know that these were the angles where the sine was equal to root 3 over 2? You fundamentally have to know that the sine of 60 degrees or pi over 3 is equal to root 3 over 2. If you know that, then you'll know that 60 degrees is your reference angle. So you either have a 60 degree angle in the first quadrant or a 60 degree reference angle in the second quadrant, or a 60 degree reference angle in the third quadrant, or a 60 degree reference angle in the fourth quadrant. And that's how I came up with all of those angles. At the end of the day, if you don't have a handful of values where you know them kind of off the top of your head, like what is the sine of 30 degrees, what is the sine of 60 degrees, what is the sine of 45 degrees? These problems can be a little bit harder, trying to work backward and think about what angles give you what answers. So you may want to have a refresher on the values for sine, cosine, and tangent for those angles 30, 60, and 45. So looking back at the unit circle. All right. right, so solve by factoring. Find all the solutions of each equation on the interval. So now notice that instead of asking me to find all solutions, it's only asking me to find solutions over the unit circle. So now I can just give only the answers that satisfy on the unit circle. All right, so our equation here is cosine x sine x equals 3 cosine x. Okay, so let's factor this guy. So I'm going to start by moving this guy over here. Then I might notice that both of these terms have a cosine in them. So I'm going to factor out the cosine. When I factor it out here, I'm left with sine x. When I factor it out here, I'm left with 3. Now I can apply the zero product property. If two things multiply to give you 0, one or both of them equals 0. So either cosine x equals 0 or sine x equals 3. Well, this is never going to happen. Right? The sine of any angle can never equal 3, so we don't even have to worry about that one. Now, over here, we just have to find all the values where the cosine of x equals 0. If we go back to the unit circle, where does the cosine of x equal 0? Here and here, right? So that's this angle, which is pi over 2, and this angle, which is 3 pi over 2. And that's it. All right, so these work the same way if you have a word problem, right? So here's a word problem. All I'm really doing is working with the equation that they give me, and I'm just trying to work it backward and solve for the angle. So here's my equation. It wants to know when is this distance equal to 90.5. So let's plug in 90.5 for D and solve for the angle. So they gave me the initial velocity was 30, the sine of 2 theta over 9.8. Let's simplify this a little bit algebraically by taking out these numbers. So this is 886.9 is equal to 900 sine 2 theta. Now we can divide both sides by 900. We're going to get 0.9854 equals the sine of 2 theta. All right, so we can take an inverse sine at this point of both sides. So I'll take the inverse sine of this number and the inverse sine on the other side of the sine of 2 theta. These cancel. And the inverse sine of this number is going to equal 2 theta. So let's take an inverse sine of this value. And we get 80.21 degrees equals 2 theta. And that means that theta is equal to 40.1 degrees. Okay, so that's if we're in the first quadrant. Okay, if we're in the first quadrant. If we're in the second quadrant, then this is going to be the sine of 180 minus 80.21 degrees, which gives us the sine of 99.8 degrees. So 2 theta equals 99.8 degrees, and theta equals 49.9 degrees. So we got two answers for this one. We get this one and this one. Remember, the sign is positive in two quadrants. So I don't really know which quadrant that I'm in, and that's why I have to solve this equation twice. Once if I'm in quadrant 1 and the angle equals 80.21, and once where I'm in quadrant 2, in which case the angle would be 99.8. All right, last set of problems. In these problems, we're working with two different trigonometric expressions, and essentially what that amounts to is that we're working with two different variables, right? Like if you had cosine x is A and sine x equals B, and you tried to rewrite this, this would be 2a squared minus b minus 1 equals 0. And you can't solve an equation that has two different variables in it. But, lucky for us, these two guys right here, cosine squared x and sine x, are related to each other, right, using Pythagorean identities. I've got this Pythagorean identity that says that cosine squared x plus sine squared x equals 1, which means that cosine squared x equals 1 minus sine squared x. So I'm going to use this identity to replace cosine squared x with 1 minus sine squared x. Okay, so this is going to become 2 times 1 minus sine squared x minus sine x minus 1 equals 0. And just like that, my equation now only has signs in it. So I have to simplify this a little bit. So this is 2 minus 2 sine squared x minus sine x minus 1 equals 0. Almost done simplifying. This is 1 minus 2 sine squared x minus sine x equals 0. And because I'm going to factor this, I'm actually going to add everything to the other side of the equation so that everything's positive. So it's going to be 0 equals 2 sine x plus sine x minus 1. Okay, so now I have to factor this. If you're not very good at factoring, it might be easier to think of this as 0 equals 2a squared plus a minus 1. Right? This would be 2a, a, right? There's the 2a squared, and then 2a and minus 1. Right? If I FOILed that out. So coming back to my original problem, this is going to become 2 sine x minus 1. Oops, sorry, that's a square. And sine x plus 1. So applying the zero product property means both of these guys are equal to 0. Okay, so you get 2 sine x minus 1 equals 0, and sine x equals a half. And over here you get sine x plus 1 equals 0, and sine x equals negative 1. This is where we're back to looking on the unit circle. Which values of x have a sign of 1/2? That is going to be pi over 6 in the first quadrant and 5 pi over 6 in the second quadrant. Which values have a sign x of negative 1? That is only 3 pi over 2. Okay, so similar type problem. We're going to make a substitution for one of these guys, cosecant or cotangent. Let's make a, let's move one of these guys over. So we'll call this cosecant x equals 1 plus cotangent x. And we will square both sides. Cosecant squared x equals 1 plus 2 cotangent x plus cotangent squared x, hopefully you recognize that 1 plus cotangent x, in other words, this guy plus this guy, equals cosecant x. It's one of our Pythagorean identities. So now we can subtract cosecant squared x from both sides. We get 0 equals 2 cotangent x. We get 0 equals cotangent x, and then we stop. For which values on the unit circle is the cotangent of x equal to 0? Right, so here's my unit circle. And I'm looking for values on the unit circle where the cotangent is equal to 0. So since cotangent is equal to cosine x over sine x, I'm basically looking for where is the cosine equal to 0, right? And that happens here and here, and therefore the answers are pi over 2 and 3 pi over 2. And because I squared both sides, I have to check to make sure that neither one of these is extraneous. So that means I have to plug it back into the original problem. If you plug in pi over 2, no problem, that works out great. If you try to plug in 3 pi over 2, it doesn't work. This guy's extraneous, and therefore the only answer is pi over 2.